Okay, we have something that sounds pretty grand, the fundamental theorem of algebra. And if we just look at this for a second, we say, if f of x is a polynomial of degree n, where n is greater than 0, in other words, you have at least x to the first power, maybe more, maybe x to the fifth, whatever, but you have at least 1, then the equation f of x equal to 0 has at least one solution in the set of complex numbers. That is not saying a lot. If you remember, a complex number has a real element to it, and then it can also have an imaginary element to it. For instance, you might have 5 plus 2i. Or, the imaginary part might be 0, and then it's all real. It's a real one. Or maybe it's the other way around. The real isn't there, it's 0, and the imaginary part is there, so now you have an imaginary root. But the point is, there's a solution that is at least a complex number. Like I say, that's most of the numbers that we know about. So that doesn't sound very high and mighty. But then the corollary says, if f of x is a polynomial of degree n, where n is greater than 0, then the equation f of x is equal to 0 has exactly n solutions. That's a little bit more grand there, provided each solution repeated twice is counted as 2 solutions. Each solution repeated 3 times is counted as 3, and so on. Okay, so they have a little thing up here where there's an example. X to the third minus 5x squared minus x squared minus 8x plus 48. It can be written like this. So when we see that, we're like, hey, this happens twice because it's squared, and it does. You see it happens twice. So we have to say, well, x is equal to negative 3 for this one. And then we say, well, x equals 4, but then it also equals 4 again because it happens twice. Okay, so we repeat it both times, 2 times. So we count this as 3, even though there's only 2 numbers, negative 3 and positive 4. Okay, so it seems like a technicality, but anyway, it's still true. The fundamental theorem of algebra says you look at that right there, you say x to the 3, okay, I have 3 roots. Some kind of roots. They may not all be real, but anyway. So here we go, we say x to the third, I know I have to have 3 solutions, x to the third, okay? And the solutions are 1 real and 2 imaginary, okay? Which I might get from the quadratic formula. And then this is x to the fourth, so I know there's 4 zeros. And they're all real, but get this, one of them gets repeated 3 times, so it only seems like 2. Okay, so let's see what we have down here. Identify the number of solutions or zeros. Well, there's 3. And we're going to go, they tell us, they say the solution's up here, so I feel like we should go ahead and find out exactly what they are. We could just say, hey, there's 3, the end. You told me if I identify the number of solutions or zeros. Well, let's go ahead and factor this, and hopefully you can see this is by grouping. We're going to say x squared factors out there, and I have x plus 7 left over behind. And you say, I'm going to take out an 8, and I get x minus 2, and you're like, hey, that doesn't work. And I say, well, okay, I have to acknowledge it doesn't work. So I have to do it some other way. I had to try, right? I had to try. So I say here to myself, 16, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, plus or minus 16. These are my factors of 16 over 1, so I'm not going to worry about the bottom. So let's get busy. I didn't put a graph for this one, so I just have to hope I get something here. So 1, 7, 8, and negative 16. Alright, 1 comes down, 1, 8, 8, 16. Oh my goodness, it's good to be lucky. Anyway, So that's x minus 1 times x squared plus 8x plus 16. Okay, so just to be clear, the positive 1 goes with the negative 1 to make 0. And then I use these numbers. Okay, just so you see where I'm getting this. Alright, can I factor this anymore? Well, I think I can. I can say x minus 1, and this is going to be x plus 4 times x plus 4, right? I get a middle term of 8x if I say 4x and 4x, right? Alright, so that means that my solution is x equals 1 and x equals minus 4, and then it happens again. But the fact that it happens again doesn't mean that I don't have 3 roots. We will see that it means it's going to kiss the x-axis there.